Okay, we're going to look at another projectile problem. This time, angle, again, with delta y not equal to 0. It's page 72, number 28. And it says, a shot putter throws the shot with an initial speed of 14 meters per second at an angle of 40 degrees to the horizontal. Calculate the horizontal distance traveled by the shot if it leaves the athlete's hand at a height of 2.2 meters above the ground. So if you think about it, what's happening is the athlete's throwing the thing at a 40-degree angle this way at 14 meters per second, and this height is 2.2 meters, but it goes and hits the ground this way. Okay, so delta y is not 0 here because it starts at a different height than it ended. Regardless, we're still going to start out the same way. Set up your horizontal and vertical. Delta x is what we're trying to find. VO, we don't know yet, but we'll find. AX is 0, as we know. Delta y is negative 2.2 meters here because it ends up lower than it started. VO, not known yet. AY, negative 9.8 meters per second squared. So just like in the last one, we're going to have to find the components of the velocity. So it's 14 meters per second at an angle of 40 degrees. So we'll find the x and y components, 14 cosine 40 and 14 sine 40. Okay, so 14 cosine of 40 is 10.7. And 14 sine of 40 is 9. Okay, now we have the information. The vertical chart has all of the information filled in, so I'm going to use that to solve for t. So delta y equals VOT plus 1/2 AT squared. Delta y is negative 2.2 meters equals, I have 9 meters per second times t plus 1/2 negative 9.8 meters per second squared times t squared. Okay, so cleaning this up, you get negative 2.2 meters equals 9t minus 4.9 t squared. Okay, so this is also quadratic, but the issue is here, we can't do the whole factoring thing with factoring out a t and solving it directly because it's not equal to 0. So I'm going to have to use the quadratic formula here, and we'll go through that. First thing I want to do is get everything on one side of the equation. So I'm going to say 0 equals, and I'm going to put it in this order, negative 4.9 t squared plus 9t plus 2.2. Okay, so I added 2.2 to both sides, and I just rearranged the order on the right side. So now this is in the form of 0 equals at squared plus bt plus c, which is a quadratic equation. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. All right, so we're going to plug this in. Negative b is negative 9 plus or minus the square root of 9 squared, which is 81, minus 4 times a is negative 4.9 times c is 2.2, and the whole thing is over 2 times a, which is negative 9.8. Okay, so what I usually do is work on what's in the radical first. So 4 times negative 4 point, well, do it this way. Negative 4 times negative 4.9 times 2.2 equals 43.12. So 81 minus 43.12. 81. I'm sorry, it's plus 43.12 equals 124.12. So we have negative 9 plus or minus the square root of 124.12 over negative 9.8. Okay, well, the square root of 124.12 is 11.11. So I have negative 9 plus or minus 11.11 over negative 9.8. Okay, since I'm dividing by a negative number, the only one that makes sense is if I have a negative on the top. In other words, if I add positive 11.11 to negative 9, I'm going to get a positive number divided by negative 9.8 and get a negative time, which makes no sense. So the time here is going to be negative 9 negative 9 minus 11.11 divided by negative 9.8, which is 2.05 seconds. The other time is negative because it doesn't really happen. If you think about it, what the mathematics is saying is there's two times at which the object would be a height of 0. One is when it hits the ground here. The other one is if you imagine extending the parabola backwards this way until it hit the ground. But that never physically happened. So that's why the time is negative. So now we want the range, delta x VOT plus 1/2 AT squared. The A drops out because it's in the horizontal direction. So delta x equals, the VO in the x direction was 10.7 meters per second, and the time was 2.05 seconds. So we have delta x equals 10.7 times, all right, so we get 21.95 meters. Which seems like a reasonable answer for a shot throw.